Hey everybody, welcome back. Today we are talking about conductors and insulators. Probably a word you've heard a lot about, but it could be pretty confusing what it exactly means. Conductors and insulators. So a conductor is a material whose conduction electrons are free to move throughout most metals. Most metals are conductors. Okay, a little bit confusing, but what it pretty much means is for a conductor, it's the electrons are easily able to move around the objects. So most metals are made out of conductors. It's kind of like most of the time we think of conductors like heat. So something is a good conductor if it's like heat is able to spread to it fast or cold is able to spread through it fast. Same thing with electrons. Electrons are able to move around in it easily, like metals. Most metals are conductors. Insulators, a material whose electrons seldom move from atom to atom. Most insulators are non-metals, example wood. So what this means is that electrons would have a hard time moving. So wood, the electrons won't really move. Also with heat, if you put heat on wood, it doesn't spread so rapidly. Okay, so insulators are things where electrons don't move so rapidly. Okay, conceptual example number 4. Insulators and conductors. Telephone poles carry large wires to transfer electricity to different parts of the world. The wires have an outer layer made of plastic and an inner core made of copper. Which parts of the wire act as a conductor? So you can pause it if you like and see what you want to pick. But the answer is A, copper. So remember, metal is mostly a conductor. That's why inside this wire, it's plastic over here, there's all these electrons going through it, going really, really fast, creating electricity. So the copper wire is causing those electrons to be able to freely move easily. Okay, moving on. Why are metals better conductors than wood? A, atoms are free to move through metals easier. B, protons, neutrons, electrons are free to move through metals easier. C, electrons are free to move through metals easier. D, protons are free to move through metals easier. So the answer is C, electrons are free to move through metals easier. So remember, electrons are the lightest and smallest things. So since they're so light and small, they're the ones that are able to move the easiest. Okay, protons are way bigger in comparison to electrons. Okay, so that's why protons and neutrons don't really move. Okay, moving on. When two conductive objects touch the electrons between them, when two conductive objects touch, the electrons between them repel each other, spreading out as much as possible. This redistribution results in an equal distribution of the total charge across both spheres, while the overall charge remains constant. Okay, so we can see that there are a lot more electrons here than there are these protons, okay, or positive charges to negative charges, okay? And so when two conductive objects touch each other, there's going to be an equilibrium of, they're going to spread out as much as possible. So in this case, we have 1, 2, 3, 4, 5, 6, 7 negative charges here, and we have 1, 2, 3, 4, 5, 6, 7 negative charges here. Okay, so it's not like one's going to have 10 and the other one's going to have 4. If they're both touching each other, the electrons are going to spread out as much as possible from each other, and they'll be equal in the amounts. Okay, moving on. Object number 1 is a conductor and has a net negative charge of negative 4 charge. Object number 2 is also a conductor but has a net charge of 0. If they come in contact with each other, what will be the net charge on object number 2? Okay, so this is 1 and this is 2. So we can see these are both conductors. Okay, and we can see that we have 1, 2, 3, 4, 5, 6, 7, 8 negative charges. 9 negative charges. And then we only have 1, 2, 3, 4. Wait, hold on. So let me count. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8 negative charges and 4 positive charges. So that means it's going to have a negative 4 charge right now. This one has 1, 2, 3, 4 negative and 4 positive, meaning 0. So when they touch each other, they're going to come in contact and they're going to touch each other. Some of these electrons, since they're both conductors, are going to move to this side. So since this has -4, some of it is going to move over here. And it's going to end up being -2 on this side and -2 on this side. So it's more equally distributed. So it's going to be -2 for each one. Okay, and that means object number 2 will also have -2. Hope that makes sense. Watch it again if it doesn't. All right, next one. Object number 1. Object 1 is a conductor and has a negative net charge of -4. Object number 2 is also a conductor but has a charge of 0. If they come in contact with each other, what will be the combined net charge? So remember, right now, before they come in contact, their combined net charge is -4. Okay? And when they come and touch each other, yes, 2 of these electrons are going to move over here. But that means this side is going to be -2, and this side is going to be -2, meaning they're still going to be -4. Okay, so that's the conservation of charge, which we learned about before. Alright, hope that makes sense. Watch this video. It's a cool demo kind of showing a little bit of how this all works. And that's pretty much it. Next time we're going to be talking about Coulomb's law.